welcome back. Now we are going to do the multiple linear regression model. So first and foremost, let's clear these variables and the data set that we used earlier, because we are going to use a new data set. Simply write clear and press enter, so the data will be gone. And again, click this data editor window, and we can go to our Excel to copy the auto data that we have learned earlier in class to estimate the relationship between the miles per gallon, the fuel efficiency, against the independent variable, namely price and weight, for 74 cars. 74 different cars. So we copy this data and bring to Stata window, Stata data editor window, and paste them. So here are the data set. We can see the variable names are listed here. Now we can run the multiple linear regression just exactly like the command that you have seen earlier in simple linear regression. Regress, and then you can put the MPG as the dependent variable and price and weight as the independent variables that will determine the size of MPG. So here we have more than one independent variable, hence we call it multiple linear regression model. Press enter and you can see the results. In multiple linear regression model, we run MPG as a function of price and weight, so we can see two variables are listed here in addition to the constant, and these are the coefficient value of each and every variable. So we have learned earlier about the ESS, RSS, and TSS, number of observations, as well as the R squared. We learn about the degree of freedom in multiple linear regression. So the degree of freedom is n minus k minus 1. We know n is 74. K is the number of independent variables, 2, and 1 is the constant. 74 minus 2 minus 1, you get 71 as degree of freedom, which is listed here. So next time when you get the result of multiple linear regression, you know that on the residual row under column DF here is the number of degree of freedom, which will help you to determine the critical values and so on. We learn also hypothesis testing in multiple linear regression topic. So you can see the t-statistic that we learned earlier to determine whether the variables are significant or not. We can compute this just like what we did earlier. We take the coefficient, divide by standard error, we get the t-statistic. So these are the t-statistic for the two independent variables. And quickly, we can also look at the p-value. We know that for as long as p-value lower than 0.05, the significance level, the variables is significant. So we can see here the p-value for price is 0.567, which is greater than 0.05. It is not significant. But for weight, it is very small, smaller than 0.05. Therefore, weight variable is significant. And we also have done the 95% confidence interval, and in the decision rule that we learned earlier, for as long as this coefficient value within this lower and upper bound of the 95% confidence interval, the variable is then significant. So variable weight is significant, but variable price is not significant based on the p-value and confidence interval. And we also learned about the adjusted R squared, the value of adjusted R squared when we take into account the degree of freedom. Finally, we have this F-test. Remember, the F-test is meant for overall significance of the model. So we have this F in bracket 2, 71. 2 is the number of k, which is the two variables here, and 71 is the degree of freedom. The f statistic is 66, and f p-value is 0.00, which means it is, or the model is on overall significance because the p-value is less than 0.05. Thank you.